Hello, this is Mrs. Ward, and this video is going to go over section 7.5, operations with matrices. In this section, we're going to decide whether two matrices are equal, add and subtract matrices, and multiply matrices by scalars, multiply two matrices together, and then we're going to use matrix operations to model and solve real-life problems. So let's begin with a matrix. As you know, a matrix can be denoted with uppercase letters such as A, B, or C. And then inside the matrix, you have elements. So this A11 is an element. And it's denoted A11 because it goes by the row and column number. So A11 means row 1, column 1. If I look at A32, that means row 3, column 2. So that's how they identify the elements. So the first thing I'm going to talk about is how I can tell if two matrices are equal. And the way I'm going to do that is, if I look at the matrices, every corresponding element has to be equal to the other corresponding element. So what that means is if I look in row 2, column 2, so row 2, column 2, row 2, column 2, row 2, column 2, and I look at this -3, if these two matrices are equal, it should be equal to the corresponding element, which it is. So if I got a mass to solve, if I have x plus 3, which is in row 1, column 1, that needs to equal 5x minus 1. So if I'm asked to solve for x, I'm just going to simply take x plus 3 is equal to 5x minus 1, and I'm going to solve that equation. I'm going to subtract x from both sides of the equation, and while I'm at it, I'm going to add 1 to both sides of the equation. Hope that doesn't throw anyone off. And I get 4 is equal to 4x. X is equal to 1. Also, when I look at this matrix C, I see that I can solve for y. I have two places. I can either use this one, row 1, column 3, row 1, column 3, and I can say -4y is equal to -44. Divide both sides by -4, and y is equal to +11. I could have also chosen any other combination as long as I'm using the same corresponding part of one matrix C to another. So if I wanted to solve for x, I could have used this 6x and this 6. I'm still going to get 1. So it doesn't matter which one you use. You just have to use a corresponding element from one matrix C to another. So definition of matrix addition, in order to add, you have to have two matrices that have the same order. Remember, matrix order goes rows by columns. The sum of the two matrices that have different orders is undefined. In other words, you cannot add. And then in order to add the matrices, you just add the corresponding parts. So if I have this one down here, this is a 2 by 2. And I'm trying to add it to another 2 by 2. So the order is the same, which means I can do it. Then to add, I'm going to add the corresponding parts. So I'm going to take row 1, and I'm going to row 1, column 1, add it to row 1, column 2. I'm going to add row 1, column 2, row 1, column 2, row 2, column 1, row 2, column 1, and finally row 2, column 2, row 2, column 2. So when I add those, I'm just going to add the corresponding parts. So I'm going to have 4 plus 2, so 4 plus 2, and that's going to give me 6. So when I write my matrix C, row 1, column 1 is going to be 6. Then -1 plus -1, -1 plus -1 will give me -2. Then 2 plus 0 will give me 2. And finally, -3 plus 6 will give me 3. And so this is the sum of those two matrices. Let's try another one. So here, for example B, I have 3 rows, 1 column, so I have a 3 by 1. I'm trying to add it to 3 by 1. I can do it. So this one's very simple. I'm just going to add 4 to -2, and I'm going to get +2. -6 plus +3, -3, 0 plus 1, and get 1. So my answer is going to be the matrix 2, -3, and 1. Looking at number C, the first matrix C is a 3 by 3. second matrix is a 3 by 2. So since they do not match, I'm going to say that this is not possible. And the reason why it's not possible is because I'm going to have this whole extra column that I'm not going to have anything to add it to. So it's just undefined. So you can either write undefined or not possible. Last one, I have a 2 by 2. And I'm trying to add it to a 2 by 2. So I'm doing -2 plus +1, which will give me a -1. 3 plus 4, 7. 6 plus -5 is 1, and 0 plus 8 is 8. So my matrix is -1, 7, 1, 8. That's not difficult at all. So when I do a scalar multiplication, a scalar is defined, a scale is a number. So what you're doing when you do multiplying a matrix by scalars, you're just multiplying by a number. So you're going to have a number out in front. And I think I already have this one done for you on the note sheet. All I'm doing is I'm taking the 4 and I'm multiplying by everything in the matrix. So I'm going to have -4, 8, 20. And then my second row will be -16, 0, and 28. And that's all I have to do when I multiply by a scalar. And that's going to come in handy when I try and solve some matrix equations. So let's look at the matrix equation and I'll come back to these. I guess I won't. All right, so the properties of matrix addition and scalar multiplication is it does not matter that the order that you add in. It does not matter if I add A and B first or B and C first. This one would be adding B and C first, then adding A. That doesn't matter. Scalar multiplication, it doesn't matter the order that I multiply. If I take 1 times any matrix, I end up with 1. When I use a scalar matrix, I can either multiply by each matrix individually, or I can add the matrices first, then distribute the C. So those properties are the same that you're used to from Algebra 1 and any normal equation. So when I go to solve this, I have 2x minus 2a is equal to b. Remember, the capital letters represent the matrices. So A is this matrix, B is this matrix, and I'm looking for a matrix X, and that really should be a capital X. I'm sorry about that. So when I go to do this, what I like to do is I like to solve the equation for X on one side by itself. So I'm starting off with 2x minus 2a is equal to b. I want to isolate this matrix on one side by itself, so I'm going to add 2a to both sides. And even though it's a matrix, it still works like algebra. So I'm going to have b plus 2a. Then in order to solve this, I would divide by 2. But in matrix world, we don't really divide, we multiply. So instead of dividing by 2, I'm going to multiply by 1/2. So I'm going to take this whole thing and multiply by 1/2. So matrix X is going to equal to 1/2 the matrix B plus 2 times the matrix A. So when I'm going to write that with my matrices in place. So I'm going to say matrix X is equal to 1/2. And then I'm going to do matrix B, which is this -4, -8, -2, 0, 14, and -6, plus 2 times 0, 3, 2, 0, -4, -1. So the first thing I'm probably going to do, according to order of operations, is I'm going to distribute this to the scalar inside this first matrix. I'm going to have X is equal to 1/2. I'm going to have this matrix is just going to come down. Oh, and that's actually a +2. No, that's a -2. And then distributing the 2, I'm going to have 0, 6, 4, 0, -8, and -2. Now I'm going to add those two matrices. Okay, so I added those two matrices together. I added -4 plus 0, got -4. -8 plus 6, got -2, so on and so forth. So I end up with the matrix. And the last thing I have to do to solve for matrix X is multiply by the scalar of 1/2. And we'll multiply every single element inside this matrix by 1/2 or divide by 2. I'm going to get -2, -1, 1, 0, 3, and 2. So that is the answer I've solved for matrix X. Okay, definition of matrix multiplication. In order to do matrix multiplication, the matrices do not necessarily have to be in the same order, but the number of columns has to equal the number of rows of the second matrix. So what that means is if I have a 3 by 2, I'm going to jump down here. If I have a 3 by 2 matrix and I'm multiplying it by a 2 by 2, I could not add those two matrices because they don't have the same order. But in order to multiply, I'm going to look for the number of columns of this first and the number of rows of the second. If those two are the same, that means I can do the matrix multiplication, and my resulting product or the resulting matrix that I would get would be whatever's left on the outside. So in this case, it would be a 3 by 2. And we're going to go through exactly how we multiply matrices in a minute. So the next one, I have a 2 by 3. I'm trying to multiply it by 3 by 3. Again, these two numbers match, and I am going to get a 2 by 3 as my resulting matrix. What's interesting, let me hop back here to number 1. See how I have a 3 by 2 and a 2 by 2? I can multiply that. But in regular multiplication, we could switch the order and it would be fine. Like if this were matrix A and this were matrix B, you know, A times B, in algebra, B is equal to B times A. But in matrix, that's not the case. If I were to switch the order and make a B times A, this B is a 2 by 2. This A is a 3 by 2. So these two numbers do not match, which means this one is not possible. So that's something that's interesting about matrices, is that the order that you multiply the matrices in matters, and it does change your answer. So be careful that you write it in the order that was given. So in C, I have a 2 by 2 times a 2 by 2. These twos are the same, and my resulting matrix is going to be a 2 by 2. Going down. On D, I have a 3 by 1 and a 1 by 3. These match, and when I multiply, I'm going to end up with a 3 by 3. E, 3 by 2 times a 3 by 2. They're the same size. I could add them, but since these two dimensions don't match, it is not possible for me to multiply these two. And then the last one, F, I have 2 by 3 times a 3 by 4. These two match, and my resulting matrix will be a 2 by 4. Now let's work on actually finding the product of two matrices. So when I have these two matrices, I have A, which is a 3 by 2, and I have B, which is a 2 by 2. So these two numbers match, so I know I can multiply them, and my resulting matrix is going to be 3 by 2, which means I'm going to have 3 rows and 2 columns. So when I go to do this, I like to use highlighters, but I can move my highlighter. You can't. Sorry about that. So I'm going to take row 1 and column 1. So I'm going to start with that. And so when you do, you have to do row 1 times column 1, row 1 times column 2, and so on and so forth. And that's why those dimensions have to match the way they do. So I like to write myself a note that I'm doing row 1 times column 1. So I'm going to take negative 1 times a positive 1. So that's row 1, column 1, row 1, column 1, plus, and then 4 times 0. And when I do all that, I get negative 1. And that's my answer that's going to go in row 1, column 1. So over here will be my answer matrix. I'm going to have 3 rows and 2 columns because that's what I guessed here. So row 1, column 1 is going to be a negative 1. Now I'm going to stick with row 1. So I'm going to stick with row 1, and now I'm going to find column 2. So in order to do that, I have row 1 highlighted. I'm now going to highlight column 2. So I'm going to slide this over, and that's what I'm going to do. So when I do that, I am going to have negative 1 times negative 2. That's row 1, column 1. That's negative 2 plus 4 times positive 7. And when I do that, I get 2 plus 28, which is 30. So row 1, column 2 will be 30. I can close this matrix. See? So I've multiplied row 1 by every single column that I can. So now what I'm going to do is I'm going to start on row 2. So I'm going to slide this highlighting down, and I'm going to start with row 2, column 1 to keep some type of consistent order going here. So I'm going to have row 2, column 1, and I'm going to do positive 2 times positive 1 plus 0 times 0. So 2 plus 0 is 2. So row 2, column 1 will be a 2. Now let's do row 2, column 2. So now this highlighting is going to shift over to here. And when I do that, I'm going to have 2 times negative 2 plus 0 times 7. So I'm going to get negative 4 plus 0, which will be negative 4. So row 2, column 2 will be negative 4. Going to keep this pattern going. I've already done everything for row 2. So now I'm going to adjust my highlighted areas, and I am going to want to do row 3, and I'm going to start with column 1. So when I do that, row 3 times column 1 is going to equal 1 times 1 plus 2 times 0. So 1 plus 0 will be 1. So row 3, column 1 will be 1. And finally, I'm going to do row 3, column 2. So shifting that highlighting over, I'm going to do 1 times negative 2 plus 2 times 7. So negative 2 plus 14 will be a positive 12. So row 3, column 2 will be a positive 12. And here's my final answer. Notice that it is a 3 by 2, which was what I was anticipating. Okay, this one to find the product, AB, just to check it, I have a 3 by 3. I'm multiplying it by a 3 by 2. These match. That's good. I'm expecting to get an answer of a 3 by 2. So I'm going to pause the video. I'm going to pause the recording of the video. I'm going to show all the work. I want you to be working on yours too, and we're going to just see if our answers match. You can check it when you turn it back on. I like to write the notes back here how I wrote row 1, column 1. So in case you do it in a different order, you can check and see if our individual elements match. I like writing this little notation as to what I'm doing, so I kind of suggest you do it too. All right, so I'm pausing the recording, and good luck. As you can see, I finished doing the product. I've written my work here for row 1, column 1, row 1, column 2, so on and so forth. And this is my final answer. If your answer does not agree, you might want to pause the video and see where you made your mistake. Hopefully you made the mistake and I didn't, but I'm sure you'll let me know. All right, the next one is an application product problem. We have a fruit grower raises 2 crops which are raised on 3 different outlets. Table 1 shows below how many units of each crop are shipped to each outlet. So the profit for crop 1 is $3.75, and the profit for crop 2 is $7. I want to find the profit for each outlet center. So I'm going to set this up as a matrix. The first thing I have is the information that's given to me is the 3 outlets and the 2 crops. And the way it's written, this is given to me in a matrix because I'm going to take out all the words. I'm going to write a matrix that is going to be 2 rows by 3 columns. The information I have here for profit, I'm going to have 2 items. So I have a choice. I can either make it a 2 by 1 matrix, where I have 2 rows and I write 3.75 and $7, and I make it a 2 by 1 matrix, or I can make it a 1 by 2 matrix where I write $3.75 and then $7, where I have 1 row and 2 columns. Well, if I go back up here, I'm going to multiply, and I have this 3 by 2. So in order for this to work, checking these two dimensions, the second number is going to have to be a 2, so I'm going to have to do the 1 by 2 so that these two can match. If I did it the other way, I'm not going to be able to multiply. So I'm going to write all my information down as two matrices being multiplied by each other. So when I do that, I'm going to write the profit as in my 1 by 2 matrix, 3.757, and then I'm going to write my numbers of items sold in each outlet, and then I'm going to multiply these two matrices together. So I want you to think about this. When I take row 1 times column 1, so when I take row 1, which I'm just going to have row 1 times column 1, what I'm really doing, if you go back up here to the words, is I'm taking the profit for crop 1 times outlet 1. I'm taking the profit for crop 2 times outlet 2. And that first one that I had, that answer that's going to go in row 1, column 1 for my answer, is going to be the amount of money or the amount of profit that I make in the first outlet, or outlet number 1. So doing this, I'm going to have row 1 times column 1. Oopsie, that's way too thick. Row 1 times column 1. And I'm going to have, when I multiply 375 times 100 is 375 plus 875, and that's going to give me 1250. I've multiplied row 1 by everything I can, so now I'm going to do row 1 times column 2. I'm going to do that. I'm going to get 281.25 plus 1050, and that total profit is $1,331.25. Because I'm assuming it's dollars. Oh, I know it's dollars. And then row 1, column 3 is going to be 281.25 again, plus 700. Oopsie. And I'm going to get 981.25. So my matrix, going back up here, is going to be a 1 by 3. So I'm going to have 1 row, 3 columns. So 1 row, 3 columns will be 1250 and 1331.25 and 981.25. This is outlet 1, this is outlet 2, this is outlet 3. So this is a profit for outlet 1. Profit for outlet 2 is $1,331.25, and the profit for outlet 3 is $981.25. The last thing we have to talk about is solving systems with matrices. Oh, there's an extra one. So if I want to solve for matrix X, if I want to solve this using linear systems, I'm going to have to put it in a form where I say that AX is equal to B. A is going to be my coefficients. This X matrix is going to be my ordered pair XY, and B is going to be my solutions. I don't know why it's doing that. Solutions. So when I first write my matrix, I'm going to write my coefficients. So I'm going to have 2 rows, 2 columns for my coefficients. So I'm going to have -1, okay, sorry about that, and hopefully I was able to cut that out, but if not, you saw my mistake. All right, so example A is I give you the matrix A times AX is equal to B. Again, the A is the coefficient matrix. That means it has all the coefficients in it of the variables. X, the matrix X will be the variables, and then B would be the answers. So what it wants to know is this question is asking, is 6 negative 2? In other words, if I put 6 into this X matrix, will I get the answers of negative 620? So we're going to check this by multiplication. So what we're going to do is we're going to rewrite this. So we have our coefficients, and our coefficients going in order are negative 2, negative 3. So the way I like to think of this is row 1 is equation 1, and then column 1 would be the x coefficients, column 2 would be the y coefficients. So when I go to do equation 2, that's going to be 4. That's a 4. I don't know why it's doing that. And then the y coefficient is a 2. I want to see that if I multiply it by what they say x might equal to, which is 6 negative 2, I want to see if I truly get the answers of my B matrix, which is going to be negative 6 and 20. So let's check it by multiplying. I'm going to do row 1 times column 1. So row 1 times column 1. So I'm going to take negative 2 times 6 plus negative 3 times negative 2. So this will be negative 12 plus positive 6, which is equal to negative 6, and that does check with that one. Row 1 times column 2. I'm sorry, row 2 times column 1. There is no column 2. I'm going to get, and that's a 4. That won't let me write a 4. So this is 4 times 6 plus 2 times negative 2. So this will be 24 plus negative 4, which is in fact 20. So it does work, so I'm going to say yes. The matrix 6, negative 2 is a solution. I don't know why it's doing that. All right, moving on. So this is the one that we started. I am actually going to try and solve this matrix C. So I'm going to put it in the order that I had before. So I'm going to write my coefficients. So I'm going to write my coefficient matrix, which is negative 1, 1, negative 2, and 1. I'm going to multiply it by, let's turn on. So what I'm going to do is I have my coefficients times my x, y, and I'm going to see if that's, I want to solve for those answers. So that's the way I write it as a matrix C. Now when I go to solve this, I'm going to put it into the augmented matrix. I'm going to have negative 1, 1, negative 2, 2, negative 2, 1. Sorry, those are my coefficients. Then I'm going to put those 3 dots and put my answers. And then remember, I want to turn the left side of the dots into the identity matrix, and I'm going to follow that pattern that I've been following for a while. I'm going to add row 1 and row 2 in such a way that the x is eliminated. So I am going to take, I should probably write this, no, I'll do, okay. So I'm going to take row 1, and I'm going to multiply that by negative 2. So negative 2 times row 1, and that'll be 2, negative 2, negative 8. And then row 2, I'm going to copy down, and that's going to be negative 2, 1, 0. So over here, I'm going to write my matrix. Row 1 has not changed. And row 2 is now, when I add these, I'm going to divide by negative 1. I'm going to get 1 and 8. So this will be 0, 1, 8. Now I'm going to add row 1 and row 2 in such a way that this y will be eliminated. So I think what I'm going to do is I'm going to multiply row 2 by negative 1, leave row 1 alone.
Good afternoon, Junior. Just a reminder to go directly.
So when I do that, so now I'm going to combine row 1 and row 2 to eliminate this y right here. So let's say I multiply row 1 by negative 1, so I'm going to have negative r1, so that would be 1, negative 1, 4, and I'm going to add row 2, which is 0, 1, and 8. Add those and I get 1, 0, and this is negative 4, 4. So then my final matrix would have the identity on the left, so the 1, 0, 0, 1, and then on the right, after those dots, I would have 4 and 8. So my ordered pair x, y, the solve of the system would be 4, 8. Okay, the next example is one where you're going to be asked to multiply, and that's going to be the third question for the quiz. So I'll give you a minute to do it. And as promised, here's all my work for multiplying the two matrices. I should end up with a 3 by 2. You can pause the screen, check your answers if you didn't get the same answer, and I hope you have a great day. Thanks for listening. Bye.